Why multi-pocket filters are preferred over single-layer filters in dust collection systems. Have you ever wondered how industrial air filtration systems manage to handle massive volumes of dust without breaking a sweat? Or how they balance energy efficiency, filtration performance, and durability all at once? In industrial environments, where high volumes of airborne particles and contaminants are a constant challenge, air filtration isn't just important, it's critical. This is where multi-pocket filters, also known as multi-pleat or multi-bag filters, come into play as a high-performance solution. Unlike traditional single-layer or flat panel filters, multi-pocket filters feature multiple pleated compartments, significantly increasing the effective filtration area without increasing the filter's external size. This design enhancement enables greater dust holding capacity, improved airflow distribution, and higher filtration efficiency over extended service intervals. The key advantages: reduced pressure drop and lower energy consumption, thanks to reduced air velocity per unit area. Optimized particle retention, improving air quality and process reliability. Even dust loading across a wider area, which minimizes abrasive wear and extends the filter's operational life. And of course, enhanced capacity to handle heavy dust loads, making them ideal for harsh industrial environments. In short, multi-pocket filters outperform single-layer filters by offering a smarter design, superior performance, and a longer life cycle, all of which translate to lower operational costs and higher system reliability. In the next slides, we'll break down exactly how each of these characteristics contributes to their performance and why they're the preferred choice in modern industrial air handling systems. When it comes to efficient dust collection, the filtration area is everything. And that's exactly where multi-pocket filters shine. Imagine a single flat sheet of filter media. Now fold that sheet into multiple pleats or pockets, like an accordion. What happens? You've now packed several times more surface area into the same outer dimensions. This increase in surface area directly impacts the air-to-cloth ratio, or ACR, a key performance metric in filtration design. Air-to-cloth ratio is defined as the volume of air flowing through a unit area of filter media per unit time. Now let's put theory into numbers with a practical comparison between a single pocket and a multi-pocket filter. Assuming both have the same outer dimensions and are subjected to an identical airflow of 1,800 cubic meters per hour, the key difference lies in the filtering surface area. A single pocket filter offers just 0.4 square meters of filtering area. In contrast, a multi-pocket filter increases that dramatically to 2.4 square meters, thanks to its pleated design. This has a direct impact on the air-to-cloth ratio, which tells us how much air passes through each unit of filter surface. For the single pocket filter, the ratio is 4,500 cubic meters per hour per square meter, meaning a high velocity, higher strain on the filter. But with the multi-pocket filter, the ratio drops significantly to 750 cubic meters per hour per square meter. That's nearly 6 times lower. What does this mean in real-world performance? Lower air velocity per unit area, which reduces the risk of media damage and improves filtration efficiency. Lower pressure drop, leading to reduced load on the motor and less energy consumption. So, despite handling the same airflow, the multi-pocket filter performs far more efficiently, quietly, and cost-effectively, all due to its enhanced surface area. This example clearly shows why design matters and how engineering optimization, like increasing filtration surface area, can result in tangible operational benefits. Now let's dive into why multi-pocket filters are considered more efficient in industrial applications. At the heart of their advantage is the reduced air velocity per unit filtering area. When you use a multi-pocket design, you're essentially adding more fabric area within the same overall volume. With more surface area available in a multi-pocket design, the same volume of air spreads across a larger area, which means each unit area handles less air at a lower velocity. This simple change creates two major benefits. First, on the left side of flowchart, reduced air velocity leads to a lower pressure drop across the filter. Because as per fluid dynamics, when air flows more slowly through a porous medium like a filter, there is less frictional resistance between the air and the filter fibers. This means the force required to push air through the filter, which is the pressure drop, decreases. With less resistance, the motor driving the airflow doesn't have to work as hard, resulting in reduced workload on the motor. This ultimately translates to cutting down energy consumption and operational costs, a big win for long-term efficiency and sustainability. Second, on the right side, the slower air movement gives the filter media more time to interact with the particles in the airstream. This enhances particle retention, meaning fewer particulates escape through the filter. As a result, filtration efficiency increases significantly, making the air cleaner and the system more effective overall. With this larger filtering surface, the incoming dust and particulates are spread over a much wider area. Unlike flat panel filters, where dust tends to accumulate in one concentrated spot, multi-pocket filters distribute the load more evenly. This even distribution leads to a critical benefit. It reduces abrasive wear on any one section of the filter media. When air and dust repeatedly impact the same small area, it causes erosion and early failure. But when that load is spread out, no single area bears the brunt of the overflow or the particles. And the result? Increased lifespan of the filter. This means less frequent replacements, lower maintenance costs, and greater reliability for your entire air handling system. So, multi-pocket filters don't just clean better, they last longer and help you optimize your operational budget in the long run. Thanks for watching. Please like, share, and subscribe.